of given operator. For example, so this is what they look like. If you put an operator in front of this phi xt now, phi xt, you will still end up with the value lambda and here function itself again, right? So this is very important, as right, as now this is the operator. Let me introduce what these terms are. So this one represents the operator, actually momentum, or a. So a, actually here I chose the momentum previously, but you can choose, this is any operator. A could be any operator, and this is the whatever the function is. Now if you can write it like this, this is simply an eigenfunction. But if you can't write it like this, not every function satisfies uh, this format. So some functions can't ever be written like this. So those are not eigenfunctions. But if you find out an eigenfunction, you can just write it like this. So this is an eigenfunction. So lambda is called the eigenvalue. It's a value, actually. It's a scalar value, just the magnitude of this whatever the operator is, right? So this is the eigen value, right? And this is again the function itself, and this is the eigenfunction. Now you can clearly see that if you put the operator in front of the function, if it is an eigenfunction, you will straight away get a value. For example, if this is momentum, this lambda is the momentum operator. The lambda represents the momentum of this particle, right? If this is the Hamiltonian, this one represents the energy. It's like that, right? So it follows the relevant operator, right? So now imagine now I chose the, right, I'm going to show you one example. So I'm going to choose the momentum operator. If you have never seen the momentum operator before, I'm going to introduce what momentum operation is. That is minus I h bar here, dabba over dabba x. You already know that what the dabba terms represents here. So and now right now let me take my function as this one. Now imagine there's a particle. You don't know what the particle is. I don't really want to define what the particle is, but there's a specific particle phi, right? It obeys this